Hello, this is Jacob Briggs, and I am here to go over Project 2 implementation for the concepts we went over. So, first on the list would be loading from JSON, which I did over here. No, that was over here. Um, so, for loading with JSON, I decided to find a way to do like player prefs, but in JSON instead. So, um, I just set up a simple volume. Let me open up to the menu here actually. Scenes, menu. So I have a simple menu right here with a volume slider. Um, and so what this will do is if I call the save function, it will make a new JSON object. The example I looked at used simple JSON, so I am using simple JSON. I make a new JSON object. I add in my volume, which is put in there with the tag volume. So in the JSON, it looks like volume and then a comma and then the amount of what it is right now. And I just debug.log what is in there. And then here, we get a path to a JSON object inside of our Unity. I believe it's inside Unity. Uh, we will make a settings save.json, and then we will write all of our JSON text up here in settings.json to string into here, and then it's saved. And then here in our load function, we grab our settings save.json and we sift through it, we read all the text, and we parse through it and see what all we can find. And then down here, we're able to grab, say, our volume slider, our volume amount, and set it back to what this was, if it's changed at all. And then down in our update, we just have a simple save and load. So if we come back over to here, let me go to console just to look. If we press S, it saves our volume as where it is. There's only one weird thing with it. I guess it would help if I turned on noise for this one. So this works. It changes the volume up and down. So we'll save it. You know what, we'll save it up here. We'll bring it down here. Definitely quieter. If we press L now, it gets louder, but it does not grab the it doesn't move the slider back up, but it does change the volume. So that's a bug here that I'm going to have to fix. But the general idea of the saving and loading from JSON is working there. Let's just turn sound off because I don't think we'll need it. I don't want it to be blaring over me. Okay, and then next is from a resource file, which is over here in the UA tanks. In Tank Shooter, now, instead of when we instantiate our bullet, we don't just grab a, what do you call it? We don't just grab a prefab and shoot it. Instead, we go into our resources and we load in our prefab. So if we come over to our resources file, where you go? Oh, right, because it's in assets. Resources, we have sphere, which is our bullet. And so what this does is every time the shoot function is called from tank shooter, it will grab our resources. It'll resource.load our sphere as a game object, and it will shoot it. So let's just load into the game. There's a weird bug right now. I don't know why it happens. That it'll oh, and this time it's not doing it. When I was working on this before, it was loading it in as a as a split screen every single time for some reason, even when I had it unselected. So that's cool that it's not doing that. So as you can see now, when we tank shoot, it still works just the way it should. Okay. And that could be used to also load in, if I went back through, it could also be it could also be used to load in our power-ups when they spawn in as well. So next is interfaces. This one was fun, and also in my interfaces I use getters and setters. So now we have our damage interface, which sets up a simple iDamageable that says anything that uses it will have this take damage function. So let's come into take health, and here is our setup for the player. The player just has take damage, it grabs from mono behavior and iDamageable. It just uses take damage to minus from the current health because their death and spawning is handled somewhere else. So it does not need to be handled in here, but in the enemy tank health now, we have our iDamageable, and inside of our take damage here, we see our health, which is from our getter and setter. Hey, stop making noise. Hold on 1 second. Okay. So our take damage sees what our current health is, which is from our getter, which returns our current health. And it will minus the health amount, which looks the same, but it wouldn't have been if I didn't set up the getters and setters here. So our getters and setters will use this. It will get our current health, and it'll be checked here to see if they're still alive, or see if they can take damage. And then here, it'll clamp our health between 0 and our max health, which is set up here. And if the health becomes less than or equal to 0, by some weird thing, if it manages to get past the 0 clamp, it will destroy. Before I used getters and setters here, this also had the death in here, but I thought because in the file it did say if you were trying to change it in here you had to use getters and setters, so I thought it'd be a good spot to use getters and setters as well. A little double thing there. Alright. Just gonna plug in my headset so it doesn't die. Namespaces is a make one random function, which would be here in empty waves. So what I did here in empty waves is I set up a super random or random, so we can call this random, and the purpose of this function is to allow for easier, it says allow for pieces of a puzzle, but I was thinking it could also be used to spawn in things like enemies in different spots each time you load into a room. So it's kind of a generalized shuffle random function for me to call whenever I might need it. And I know it defeats the purpose a little bit, but we call the system.random inside of it to help along with the overarching purpose of random, so that we don't have to write this each time. We just have to call superRandom.random. and then we can do this same thing. So down here we have a shuffle, and it takes in a list. And it doesn't need to have a type. It uses the T so that it says it doesn't matter what type it is, it'll shuffle no matter what it is. And then we come in here, we get our list count, we get how long it is, and while our n is greater than 1, we will come down here and we will minus from one of those, we'll minus from the overall value, and we will shuffle up the values so that they are in random order each time the shuffle is called. And then down here we have our answers, which is a list. We have our answer points, which is a list. We get our super random.random and call it shuffle answers. And then we come down here, we shuffle our answers for our actual answers here. And then down here in update, we say while answers.count is greater than 0 and answers points dot count is greater than 0. We will grab the last answer and the last point, and we will instantiate the answer at that point, and then we'll remove them. So every time we load into our main lobby, which I believe is hub, yes, every time we load into our lobby, the answers up top should be in a different order. And then this could be applied to other random things for like any parts of a puzzle, any other puzzles that might have something like this. Go away. We can use that same random because it's not just one list. As long as there's a list involved, we can shuffle it and then we can call it. Next on the list would be getters and setters, but we talked about that. The next are in OOP, which I'm not sure if talking about them in regards to, because these are the one things I didn't go back and like re-look at, because I know in here and the power-ups I can close out of empty waves now, actually make it easier, because I know in here I had a power-up, it was a class, it set up all of our functions, and then in power-up damage or in all of our power-ups actually, you just come in here, it inherits from power-up and gets all of its things. And then I've seen multiple things about polymorphism, but one of the things about polymorphism was overriding. I'm not sure if that's actually what it is, but if it is, then these also override our functions from power-up to do certain things when they go. And then encapsulation was things that were private and they couldn't be called outside of it. So I thought that my getters and setters here in enemy tank health, which are both private, for the health and max health, they can't be called anywhere else except for right in here, would be a good example of encapsulation, maybe. Abstraction, on the other hand, I have no examples to show for that. But I believe that covers everything, so thank you for watching. Goodbye.